Here are some examples from the day 43 assignment. Here we're working with trig ratios. They want us to find the tangent of each angle that is not the right angle. So tangent of angle A and tangent of angle B. Well, we know from SOHCAHTOA that tangent is opposite over adjacent. So if we look at angle A, the opposite leg to angle A is 4, the adjacent is 3, so that would be 4 over 3. Since they don't, they have them as a decimal, 4 divided by 3 is 1.33. So that would be the tangent of angle A. Now for angle B, the opposite leg is the 3, the adjacent leg is the 4, so that would be 3 over 4. They don't have 3 over 4, they have it as a decimal, so that would be 0.75. Find the tangent of each angle that is not the right angle. So here, the tangent of R and the tangent of P. Tangent is still opposite over adjacent. So if we look at R, opposite of R is 7. The adjacent leg is 20. So 7 divided by 20 should be 0.35. And if you didn't realize from the last one, the tangent of the other angle is going to be the reciprocal. So this was 7 over 20. This is going to be 20 over 7, which looks like it's going to be 2.86, approximately. That's rounded. Okay, let ABC be a right triangle. Measure of angle C is 90. Given that tangent A is 1.25, find the tangent of angle B. Well, we just saw in the last one that the tangents are reciprocals of each other. So what we would want to do is tangent of angle B would be just 1 over 1.25. Instead of 1.25 over 1 divided by 1.25. That should be 0.8. Well, let's see, just to be sure. 1 divided by 1.25 is 0.8. Okay, the length of side QR is approximately blank units. So it looks like they want us to round here to the nearest tenth. QR. Okay, so everything revolves around the angle that they're giving us. Here they're giving us a 63-degree angle. Based on that 63-degree angle, QR is the adjacent leg. And they're giving us the opposite leg. So the trig ratio that relates opposite with adjacent is tangent. So I'm going to take the tangent of 63, and that's going to be equal to specifically the opposite over adjacent. So the opposite is 7.4, and the adjacent is what I'm looking for. So now I'm going to have to solve for x. I'll show you a shortcut. Regardless of the trig function that you're using, if you're looking for the side that's on the bottom, then all you would do is switch that with the tangent. You would change locations. So x is going to be equal to 7.4 divided by tan 63. The key is that we're dividing. So put that into the calculator. Make sure your calculator is set to degrees. So 7.4 divided by tan 63 is going to be approximately 3.77. They want it to the nearest 10, so that will be 3.8. 3.8 units. Okay, side DE. Based on this angle that they're giving us, DE, is the adjacent leg, And what they're giving me, 14, is the opposite leg, so this is still going to be tangent. So tangent of 24 is equal to the opposite, which is what they're giving us, the 14, over DE. Okay, we'll just go ahead and put DE there. So just like the last one, we're looking for the side length on the bottom of the fraction in the denominator, so I can just switch and say DE is equal to 14 over tangent of 24. They want this to the nearest tenth. 14 divided by tan 24, and that's going to be 31.4 if we round to the nearest tenth. Find the measure of angle R. Okay, so here we don't know an angle measure. If you remember from the notes, we said we're going to end up using an inverse trig function here, so we'll see how that sets up. Let's do our let's set up our equation though. Here, in order to find an angle, they have to give me two sides, which they are, and these sides are the opposite and adjacent leg, which tells me I'm going to use tan. So I'm going to say tan of R, I'm looking for the angle, is equal to the opposite of R, which is 6, over the adjacent leg, which is 15. So here, in order to get the R, we're going to use the inverse. So we're going to say R is equal to inverse tan, the tan with a little minus 1, of 6 over 15. So go to your calculator, find your inverse tangent button. That gives me 21.8. They want it to the nearest degree. So to the nearest degree, that's going to be 22. 22 degrees. Select the equation that expresses the measure of side PQ, and then solve the equation expressing your answer to the nearest tenth. Okay, so here the angle they're giving me is 75. They want PQ, which is adjacent to that, and they're giving me the opposite again. So this would be then tangent of 75 is equal to the 38 over PQ. So I told you just to switch. When you want the one on the bottom, PQ equals 38 over tangent of 75. So that's going to be B. And then when we put that into the calculator, 38 divided by tangent 75, that gives me to the nearest tenth is 10.2. Okay, given that sine is of that sine of 30 degrees is 0.5, enter the cosine of the complementary angle. Okay, well, the co in cosine means complement. So if they wanted the sine of the complementary angle, then what you would need is the reciprocal. But since they want the cosine of the complementary angle, it's going to be the same thing. Since the cosine of the complement of this is just going to be the same 0.5. But okay, I guess first you need the complementary angle. The complementary angle, complement means add up to 90. So 90 minus 30 is 60. So the cosine of 60 is equal to the same 0.5. You can verify that with your calculator if you want. All right, cosine of B. Here they want cosine of B. So cosine is adjacent over hypotenuse. So if here's angle B, the adjacent leg is 12, the hypotenuse is 13. So the cosine of B is equal to 12 over 13. And here they want us to round 12 over 13 as a decimal. That would be 0.923. They didn't want angle B. They wanted to know what the cosine of B was. They wanted to know what the fraction was, not what the angle is. Find the unknown length of x. Okay, so here, based on this angle that they're giving me, 39, x is the opposite leg, 18 is the hypotenuse. So for our trig functions, opposite and hypotenuse is the SO. Its sine is opposite over hypotenuse. It's the SO in SOHCAHTOA. So my trig function I'm going to use is sine of the angle, which is 39, is equal to, if it's opposite over hypotenuse, that would be x over 18. So for the first time in this set of examples, the unknown that I'm looking for is in the top of the fraction. So what I'll do here is I'll get the 18 and I'll move it to the front. That's the trick. So 18 sine 39 is equal to x. I would put that into the calculator. 18 times sine of 39, and that gives me 11.3 to the nearest tenth. Yeah, it's 11.3. Okay, find the unknown length. Based on this 73-degree angle they're giving me, the x is the hypotenuse, the 16 is the adjacent leg. So cosine, and the ka is adjacent over hypotenuse. That's the ka in SOHCAHTOA. So I want cosine of the 73 is equal to the adjacent is 16 over the hypotenuse is x. So just like before with tangent, if the one that you're looking for is on the bottom, switch them. Instead of multiplying, divide. X equals 16 over cosine 73. 16 divided by cosine of 73. That's going to be 54.7. That's correct. Find the measure of angle P. Okay, so if we're going to find an angle, they have to give me two sides. They do. Based on this angle, they're giving me the adjacent leg, and they're giving me the hypotenuse. So adjacent and hypotenuse is going to be cosine. So I would say cosine of P is equal to specifically adjacent over hypotenuse, which is 9 over 19. When I want an angle, I have to use an inverse trig function. So I'll say P, which is what I'm looking for, is equal to the inverse cosine of 9 over 19. Use the calculator, and that gives me 61.7, but they want it to the nearest degree, so that's 62. Okay, another angle measure. Based on this angle, they're giving me the opposite leg and the hypotenuse. So this is going to be a sine equation. Sine of this angle U that I'm looking for is equal to the opposite leg. Opposite leg there is 10 over the hypotenuse, which is 17. So the U, when you look for an angle, you need an inverse trig. So this will be inverse sine of 10 over 17. Find the inverse button on the calculator. Inverse sine, 10 over 17. And that gives me 36. The nearest degree is 36 degrees.